Stop building fragile API wrappers that collapse under load. Let's break down the exact production-ready architecture you need. When you try to automate complex processes, the default approach is usually a monolithic script. But chaining a long series of linear API calls creates a system that fails silently the moment it encounters real-world production load. These failures stem from three limitations: aggressive platform API rate limits, the amnesia of stateless AI models, and absolutely no error reconciliation. This trigger to LLM to post workflow is structurally brittle. If the language model takes too long to compute or fails to respond, the entire chain drops the data, and the final execution never happens. To achieve resilience, you must abandon single-path scripts and build a decoupled, multi-platform autonomous engine. That requires splitting the system into three isolated zones. The first layer is a stateful triggering environment to store your inputs permanently. The second layer is an isolated AI compute engine to process heavy logic, which then hands the raw data off to the third layer, an asynchronous distribution router to handle the final deployment. You cannot build reliable software with one-way execution. Transitioning away from broken scripts requires a state-reconciled architecture, where every action is logged and verified. We start by establishing the memory layer. Before we process any data, we need a place to anchor it. Large language models are completely stateless. They have no persistent memory of past actions or ongoing context, which means you must maintain a dedicated external database to hold the state of your operations. We will use Notion to serve strictly as the centralized state manager for the entire system. Here is the schema for our centralized database. It requires specific parameters: a topic ID to identify the run, and a raw input field for the source text. Next, a status field controlling state: draft, approved, or published. And finally, an output URLs array for tracking. By locking these inputs into a table, you maintain context independently of the AI processing layer. The data survives even if the computation fails. A rigorous data schema gives your automation engine a persistent source of truth across entirely isolated execution cycles, eliminating context loss and preventing hallucinations. With the database anchored, we can dictate how status changes initialize the execution sequence. This is an event-driven model. The entire automation sequence sleeps until the exact moment a topic's status property toggles to approved. In this diagram, you see the status toggle flip. That instantly fires a webhook carrying our raw data. Relying on webhooks means the system executes immediately upon state change, requiring 0 manual polling intervals to check for updates. That webhook payload lands directly in N8N, which serves as our dedicated, isolated AI orchestration layer. We isolate the orchestration because AI compute is time-intensive. Wrapping long generation times inside API routing invites failure. Heavy processing needs discrete error handling. The JSON payload routes straight into an AI agent node connected to the Claude API endpoint. It splits the raw idea into two processing streams, one generating a punchy 280-character short-form variant for X, and a second reformatting the logic into a professional LinkedIn post. Notice that generation times, execution limits, and formatting constraints are entirely resolved within this compute layer long before the data ever touches the distribution router. Decoupling time-heavy AI logic from the downstream network requests ensures that extended large language model processing times never trigger cascading timeouts in your deployment APIs. Once the text variants are generated and polished, the compute layer hands the data off to the distribution layer. The N8N node packages both finalized text outputs and pushes them forward across the network via a standard HTTP request. The HTTP request arrives in make.com, operating strictly as our multi-channel distribution router without AI logic. Make instantly splits the payload. Path A sends an immediate post request to the X API, while Path B attaches scheduling logic, queuing the LinkedIn API. Operating immediate, real-time execution parallel to asynchronous, time-delayed scheduling is cleanly managed because the central router isolates the deployment logic for each. The router successfully maps the payload constraints independently, matching the specific rigid API requirements of X versus the structure required by LinkedIn. Splitting the deployment into isolated paths builds immediate fault tolerance into the system.
If the X API limits your account or rejects the payload, that specific pathway fails safely. Asynchronous routing guarantees the failure remains contained, leaving the parallel LinkedIn deployment entirely unaffected. The most common architectural flaw in amateur deployment pipelines is the open loop. Operating with a fire and forget mentality, pushing data out without verifying receipt, destroys state integrity. You never actually know if the action succeeded. The make router holds its process open, actively waiting for a 200 OK response from both APIs. Make then extracts the published URLs, bundling them into a payload that routes backward, transitioning the Notion database status to published with the populated links. Mutating the final state to published closes the loop, acting as a hard lock. This ensures the initial trigger can never mistakenly run a duplicate execution on the same data. By locking the state, you establish the exact foundation needed for automated retry logic. If a record sits as approved past its timeout window, the system knows definitively that it failed and can safely restart the process. Writing final deployment states back to the originating database transforms what would be a fragile one-way script into a resilient, self-monitoring system. Here is the complete end-to-end decoupled system operating in perfect synchronization. True automation requires you to chain deep AI logic together with highly reliable state management and independent routing protocols. System complexity and high production load can only be managed when you enforce strict isolation between your components. Look at your current deployment pipelines, audit the linear chains, map out your single points of failure, and identify where your data is operating without a verified state. Decouple your architecture. Stop just using AI tools. Build for actual resilience and start engineering your own real systems today. Treating AI automation as rigorous software architecture rather than casual tool chaining ensures that your system remains operational as your throughput and complexity increase.